functions continue. So we're gonna look at intercept here. So let me write this definition real quick. Intercept, a point where a line crosses an axis. All right, so this first one wants us to figure out where the x and y intercepts are. So the x-intercept is where I cross the x-axis, so this point right here. And then the y-intercept is where I cross the y-axis, so right here. Now, when I write my x-intercept, I'm like, oh, hey, look, it's at 4. Intercept is a point where the graph crosses the axis. So I can't just say 4, because 4 is not a point. So make sure you're writing that as a coordinate. 4, 0. That's a point. So my y-intercept, -2. 0, -2, because it's a point where my graph crosses the y-axis. Okay, next one, determine the slope using the slope triangle. Okay, so I've got my 2 points already designated here. So using my slope triangle, I rise up to and over 4. So 2 divided by 4 equals 1/2. So my slope is 1/2. Now that I have my y-intercept and I have my slope, I can actually use point slope form to now write the equation of the line, right? So y minus y sub 1 equals m times x minus x sub 1. That is my point slope form. Okay, well, I know they want me to use my y-intercept as my point, so that's this point right here. So I'm gonna make this x sub 1, y sub 1. And then my slope, I just found that is 1/2. So I'm gonna do, okay, y minus my y sub 1 is -2, so negative is +2 equals m is 1/2 times x minus my x sub 1 is 0. So I don't, I could write just x, or I can write x minus 0. Then solve for y. So if I want to solve for y here, I've got y plus 2 equals, I just have 1/2 x on this side because the minus 0 goes away. So then get that y by itself, -2 minus 2. So over here I have y equals 1/2 x minus 2. What does that look a lot like? Slope-intercept form. Y equals mx plus b, where the slope's in front of my x and my b is really my y-intercept, 0b.
Another thing we should be aware of is that there's not really like magic to y equals mx plus b. It's understandable and we're accustomed to it. But understand in other applications and other math studies, we often use different variables. So for example, if I pulled out my TI-84 and I pulled this up, it says ax plus b, and down here it says a plus bx. Now, good mathematicians should not be slowed down by this. What variable is slope? So if I go up here and it says ax plus b, slope is always with the x term. So in this case, a is slope and b is that y-intercept. If I come down here, a plus bx, then a is the y-intercept and b is slope. So let's broaden our understanding of slope-intercept form. So now we have more information and we can do a lot. We're given an example with 2 points and we're asked to write it in point-slope form and then simplify it down to slope-intercept. Keep in mind, this is how we want you to always do it. Point-slope is the best, easiest way to go, so only do it this way. I don't want to see any other methods from Algebra 1. Here we go. First, find slope. We have slope. Now, point slope form, I need slope in 1 point. Remember I told you it doesn't matter which point we use? Often I'll just use the first point, because why not? I want to just go ahead, I'm going to use the second point just to show it doesn't matter which one. Substitute the correct values. You might have also noticed that I crossed out the point I wasn't going to use because it would be completely incorrect to use the y from one point and the x from the other. So just to make sure I don't make a simple error, it's always a good idea to go ahead once I'm done with slope, cross out one of them and go from there. So y minus 5 equals -1/2 x minus a -2, so that's really plus plus. I'll go ahead and distribute because here's my point slope form. I'm going to distribute that -1/2. -1/2 times 2, well, the 2's would divide out and I would just get -1. So do be careful. And then I have y minus 5 equals -1/2 x minus 1. Add the 5 to both sides. Final answer, slope-intercept form, y equals -1/2 x plus 4. So we have slope-intercept form. One of the things that we haven't reviewed is graphing from slope-intercept form, but that's the part that you've had the most amount of experience with. So let's just do a really quick rough graph using this equation. +4, so that means I'd go ahead and go up 4, 1, 2, 3, 4 on the y-axis because this is my y-intercept, 0, 4. and then slope -1/2. When I see slope of -1/2, you have to decide whether the numerator or the denominator is going to be negative. I like keeping my denominator a positive run all the time. So if I have this slope of -1/2, I'm going to treat it like -1 over +2. So a negative rise of 1 unit over a positive run of 2. So when I go to graph this, I have my y-intercept at 0, 4, always graph that y-intercept on the y-axis, and then go down 1 because negative rise of 1 over +2. And there's my sketch. And once again, it would have been way easier just to graph it from point slope because I could have easily just done -2, 5, and then down 1 over 2. And I have the exact same thing. Fluency in math is our goal here, so always go for knowing things in multiple ways and multiple representations. I want you to give number 5 a try, and then we'll come back and see how well you did. Maybe even sketch it.
Let's jump in and check your work. So here I've got my point slope form right here. I got the slope was 2 over -3, so -2/3. I'm about to distribute this -2/3 to the 6 here so I can convert it to slope-intercept form. But to do that, I might need some side work really quick. So like 6 over 1 times -2 divided by 3 equals, okay, -12 over 3. So that's going to be -4. So I'm just going to write -4 over here, okay? And then I'm going to add my 7 so that I officially have y equals -2/3 x plus 3. So I have my slope-intercept form right here, but to get there, I used my point-slope form because that's the way we want to do it. Always use point-slope form to get slope-intercept form. I'm gonna do a quick sketch of this real quick using slope-intercept form, but remember, I could have used point-slope form, but just to practice. Okay, so my intercept is 0, 3, so I'm getting that plotted, and then my slope is -2/3, so I'm gonna go down 2 over 1, 2, 3. There's my quick sketch using slope-intercept form, even though we could have used point-slope form. Number 4, we have a big blank there and we don't know what to write, so let's just keep going. Graph f of x, g of x, h of x on the same coordinate grid. Okay, so f of x, I'm gonna graph that one in purple. This one's in slope-intercept form, so we've got our slope 3 over 1 and we've got our y-intercept 0, 2. So let's go and graph that on our coordinate grid. So 0, 2, because that is where I'm going to start because it's slope-intercept form. On the y-axis, because it's the y-intercept. So this is where I start, and I'm gonna use my slope to rise up 1, 2, 3 over 1. And then I'm gonna do it again for safety. All right, so it looks like I got a nice positive slope for f of x. Let's do g of x in blue. So why don't you pause and try to graph it while I graph it? We have g of x, let's do h. I'm gonna graph h in orange. Why don't you again pause, graph it while I graph it. H of x. This is slope-intercept form, but it looks like the slope and the intercept just kind of switched places. It's like b plus mx instead of mx plus b. This is almost to my advantage if you think about it, because I always start with my y-intercept when I'm graphing anyway, so it's kind of handy to have it there first and then identify my slope. So now I can go, okay, well, I'm just gonna work in order. Graph my -1, oh, look, it's on my blue graph too, and then rise up 3 and over 1. Now that I have all 3 functions graphed, it asks what I notice. Well, if I look, I can kind of compare f of x and h of x like they're 2 parallel lines. So I could say f of x and h of x are parallel.
Parallel would be 2 lines that extend indefinitely and never cross.
So f of x parallel to h of x. Do you remember that symbol from geometry? It's kind of a nice shortcut here. Okay, and then if I compare f of x and h of x to g of x, it looks like g of x not parallel, definitely intersects them. And if I look closely, it looks like they're perpendicular.
Perpendicular, those meet at right angles, so 90-degree angles.
So f of x is perpendicular to g of x, and h of x is perpendicular to g of x. Do you remember that symbol from geometry? Okay, so since we noticed this, what do we notice about the equations of the lines and that fact that we've noticed that some are parallel and perpendicular? Well, f of x and h of x, if I go look at their 2 equations, what do you notice is the same? The slope is the same for both of those. So if I have parallel lines, they have to have the same slope. So the only way 2 lines are parallel is if their slopes are exactly the same. If they're even just a little off, they'll eventually intersect and not be parallel.
Okay, perpendicular looks a little bit more tricky. We have f and h have the same slope of 3, but then g has a slope of -1/3. Well, 3 could be written as 3 over 1 and then -1/3. Well, I noticed that they're reciprocals, but the sign also changed. So perpendicular lines have opposite signs and reciprocal for the slope. Perpendicular lines have opposite reciprocal slope. So remember, we have to change signs and flip. Take the reciprocal. Let's practice. On 1, we're given the line y equals negative 3/4 x plus 1. Therefore, I want to determine, is this going to be a parallel or perpendicular slope of negative 3/4? Well, if the slope is negative 3/4, that is parallel because it's the same slope. Down here, slope is 4/3. Well, what happened there? 3/4 has flipped, so it's the reciprocal, and instead of being negative, it's now positive. So this is the opposite reciprocal, so that means this is my perpendicular slope. Example 2 has it a little bit different. We're not in slope-intercept form. You don't have the actual slope until you're in slope-intercept form or point-slope form. So let's go ahead and solve this for y. Now it should be clear to you that my slope is always with the x, and therefore slope is negative 6. Go ahead and find out the parallel slope and the perpendicular slope. See if you really understand it. Okay, I have a lot of faith in you. I know that you know that parallel slope is the exact same slope, so it's negative 6, but then perpendicular, 6/1, I'm gonna flip it, so 1/6, and change the sign, so instead of negative, it's now positive. So perpendicular slope is 1/6. Another way that we might encounter this problem is this next example on 3. Write the equation of the line parallel to y equals 6x minus 2 through the point 1, negative 3. Well, parallel, that means I need the same slope as this line has. Well, the slope here is 6. My parallel slope is also going to be 6. Old slope, or the slope from the original line, is 6, and the new slope, the parallel slope, is also 6. At that point, I really don't need this line anymore, and sometimes it gets confusing and you think you have to use the 2 and you don't. So it's a good idea to go ahead and cross it out once you're done. Now I have slope and I have a point, and I have to write the equation of a line. If you're not thinking point-slope equation, you haven't been paying attention. Here we go. Hopefully you remembered the point-slope form and you substituted the values correctly. The y minus a negative 3 becomes y plus 3, and therefore my equation of the line is y plus 3 equals 6 parentheses x minus 1. Remember, if I needed to graph, I can graph from this. And if they ask me specifically for the y-intercept, I might have a reason to simplify it to slope-intercept form. But if not directly asked, don't. Just stop. Okay, last example here, number 4, but we're asking for perpendicular. And it's not in slope-intercept form and it's not in point-slope form. So that means we have to go ahead and solve for y first. I think I'll stick with you through this start. So we're going to subtract the 4x, move it over. And last, to solve for y, I need to move the 2 times y, so undo multiplication, divide. Be very careful when you divide by 2 because everything gets divided by 2. So then simplifying that, y equals 7/2. You may be thinking, ooh, I don't like that, but it doesn't matter, we don't need it. Minus 2x, and that's the only part that I actually need. I needed that slope. So the old slope is negative 2, and now you need perpendicular slope and write the equation of a line. Pause the video, do it yourself. Okay, hope you got this right. So my old slope was negative 2, perpendicular slope is going to be the reciprocal, so 2/1, flip it 1/2 and change the sign, so positive 1/2. And then I went ahead to point slope form because why wouldn't I? That's the easiest. Y minus a negative 2, so y plus 2 equals 1/2 parentheses x minus 4. Boom, we got it.
Well, cool. Then it looks like number 4 was all about parallel and perpendicular lines. So I'm going to go ahead and write that in up here. So I'm keeping my notes nice and clean. Remember, parallel, same slope, perpendicular, opposite, reciprocal.